In this video, we're going to go through the summative writing for the iodine clock lab. So let's begin. We have our blank Google Doc up here, and we have the requirements for the lab right here. We're going to begin by giving our lab a descriptive title, and we want to avoid using verses in the title. The title should give the reader an idea of what the lab report is about. So this was the iodine clock lab. Don't just call it the iodine clock lab. Think about what we were investigating in the lab. We were looking at concentration and temperature and how those affected reaction rate. So ChatGPT or other sources of artificial intelligence are really great at coming up with titles. Just make sure that your title is descriptive. All right, the next section is the background. So the background information is written in present tense and should include the following information that's relevant to the experiment. So here we are going to basically take the information we looked up in the pre-lab, we are going to put it into a paragraph form, and then we are going to also include citations here at the very end of the lab. You can skip the in-text citations as the directions say here. So you're going to basically take the answers to the questions that you had in the pre-lab about kinetics, collision theory, the relationship between concentration and reaction rate, temperature and reaction rate, and put it into a paragraph form. The first thing that we're going to need is a purpose. So I'm going to create my heading for purpose. Now, the purpose of the lab, we had two. We were investigating the relationship between concentration and reaction rate, and then we're investigating the relationship between temperature and reaction rate. So in one sentence, you could say something along the lines of, the purpose of this investigation was to, present tense, is to determine the relationship between concentration / temperature and reaction rate. Done. All right, the next section is going to be safety. So if you completed the pre-lab, you should be able to take your summaries for the hazards of potassium iodate and sodium metabisulfate and work those into a paragraph. So you don't want to include general safety rules like wearing gloves, goggles, etc., but just summarize the hazards here. So use the pre-lab. Okay, it should be written in paragraph form, not in bullet points. All right, next we have our methodology. Now the methodology is going to be written in past tense and third person, meaning that you did it in the past and you're not going to use personal pronouns like I, we, or you. So you could say, let's say our first step was to measure out, I could say scientists measured out. So instead of saying we, you can say scientists or group members measured out, I don't know, what was it, 6.4 milliliters of solution B, whatever it was. Okay, so we had two parts to the lab. The first part of the lab, we were looking at the relationship between concentration and reaction rate. And then for the second part of the lab, we were looking at the relationship between temperature and reaction rate. So if you don't recall what we did in the lab, I suggest you go back and pull up the video for the lab and go through. So I don't need specific steps, but just summarize what you did. So I could say scientists, created solution A and solution B by mixing, solution A is the one that we had to mix up, by mixing an amount of with potassium iodate and water, and then combined it with solution B The reaction was then timed, and recorded. Something along those lines. But you need to give me some more detail about what was occurring and how did you know when to stop it. And then for the temperature, we did several different things here. We did it with cold water bath, we did it at room temperature, and then we did it with a hot water bath. Okay, so just summarize. It does not need to be very long because this lab didn't involve very many steps. We were just mixing solutions and then timing them. So, a paragraph or two is fine here, but just summarize what you did. All right, the next section is going to be the data tables for part 1 and for part 2. So for part 1, it's just going to be concentration and reaction time, and then for part 2, it will be temperature and reaction time. So for part 1, that was concentration and reaction time. Now, you can say, you could honestly just call that your title if you'd like, and then I'm going to insert my table. I did different concentrations, times, and then we're going to add another section here for reaction rate. And I believe we had 3 trials that we did. Concentrations units were molarity, reaction time was seconds, and then reaction rate is going to be seconds, and then it's going to be to the -1. Okay, so I'm going to put in my various concentrations. This should be straight off of the pre-lab, so I'm just going to type in some random numbers here. So I'm going to say, I don't know, 1.0, 2.0, 3.0. Obviously, don't use my numbers because I'm just making these up. And then for my reaction time, I'm just going to make up some numbers here. So I'll say 50 seconds, and then, I don't know, 30 seconds, and then how about 10 seconds? Okay, reaction rate is calculated by doing you're going to do 1 over your reaction time. So 1 divided by 50 gives me a reaction rate of 0.02. I'm going to do the same thing here. So 1 divided by 30 gives me 0.03. And then finally, 1 divided by 10, 0.1. Okay, so you'll do that for all of your trials here. You only need the first 3 trials. If you want to include the others, that's up to you, but just the first 3 trials. All right, the second data table that we had was for temperature and reaction time. I'm going to do the same thing. I'm going to insert a table. We had 3 trials, I believe, here. So this one is going to be temperature, and my units are degrees. So to get the degree symbol, I go insert, special characters, and I can just type in degree, and it will pop right up here. Temperature, degrees Celsius, reaction time, and then reaction rate. Seconds, and this is going to be to the -1. Okay, so I'm going to throw in my temperature. So I believe cold was the first one that we did. So I'll say this was maybe 10 degrees Celsius. Maybe the second one was 25 degrees Celsius. And then let's say 75. Just throwing out some numbers. Okay, so I'm going to just reverse the numbers that I had before so that I can just use these numbers. Okay, just like that. Okay, great. So I've completed my purpose, safety, methodology, data tables. Next, I want to do my graphs. So I have Google Sheets open here already. And when you graph, this is important. You want to graph reaction rate, not reaction time. So the easiest way to do this is to copy your table from before, and you can just paste this into Google Sheets. And then I'm going to delete the column that has reaction time. Okay, so I don't want to use reaction time, I want to use reaction rate. Okay, so I'm going to insert a chart. So I'm going to highlight these cells. I'm going to go Insert, Chart. Okay, reaction rate should be on our y-axis. We changed the concentration. That should be on our x-axis. And I want to use a scatter plot. So if you go down, you'll find scatter plot here, just like that. And we want to insert a trend line here. So if I go up to Customize, I want to go to Series, and then scroll down to Trend Line. So that'll give us a line that goes through our data points. Okay, so remember, when you are including a graph, you should have a title, which we have right here. So it's always y-axis versus x-axis. Now, if this is a little sloppy with the units, I can just remove those. I want to make sure units are on our axes. So if you just copy and pasted from the data table and you included the units, they should already be on there. And yeah, that looks great. So let's copy this. I can just go Edit, Copy. I'm going to go down here to my graphs, and I'm going to paste in my first one. So you want to paste it unlinked. There's my first graph. And now let's do our second graph. So again, I'm going to go up to my data table. I'm going to copy my data table. And I'm going to do a new sheet here. So if you go down and click on the plus symbol here, you can add a sheet. Again, I'm going to paste in my data. I'm going to delete the column. So if I right-click up here and go to Delete Column, that will clear the reaction time. I don't want to use that. I want reaction rate. I'm going to highlight my cells, Insert, Chart. And again, we want a scatter plot. It looks like it defaulted to that. So I'm going to go up to Customize, Series, and I'm going to click the box for trend line. So that'll show me a graph. Or, sorry, it'll show me my trend here. So I'm going to delete my units from the title just to make it look a little cleaner. And again, I'm going to click on it. I'm going to go up to Edit, Copy, and I'm going to paste in my graph right here. Again, unlinked is what we want. And there you go. There are my two graphs. And check that box. So the graph section here is worth the most amount of points. So we want to make sure that we have those graphs in there. Okay, trends. So this is where we're going to be explaining our graphs. So you're basically answering these questions. So as the concentration increased, so if I look at my first graph, as I increase the concentration, so as I move from left to right, what happened to the reaction rate? Did it increase? Did it decrease? Or did it remain constant? Now, if your reaction rate, let me type this down here. Okay, so if your concentration increased and your reaction rate increased, it is a direct relationship. Okay, so if your concentration increased and your reaction rate increased, it's direct. So one directly affects the other. If your concentration increased and your reaction rate decreased, that is an indirect relationship. And finally, if your concentration increased and your reaction rate remained the same, that is a constant relationship, or it remains constant. So you'll do the same thing for temperature. So you want to look at the graphs and you want to explain what the relationship is. And then you want to kind of bring in collision theory to explain. So think about what's going on. The molecules are moving around. Anytime those molecules bump into each other, you have the possibility for a reaction to occur. So think about concentration. You're adding more particles. How would that affect the number of collisions? The same thing with temperature. Think about that energy threshold that you need in order for a reaction to be successful. So if you increase the temperature, what's happening to the collisions. Are more of them successful? Are more of them unsuccessful if you increase that temperature? All right, the final sections are conclusion and explanation. For our conclusion, you're going to write in past tense and again use third person. You want to restate the lab's purpose. Look at that, just copy and paste. Okay. Now here, if you were able to get to the section of the lab where you were able to determine what concentration led to a 20-second color change, you're going to include that. If not, you can go ahead and skip that. Now, the next section, or the next bullet point here says how concentration and temperature affected the reaction rate. So you want to support this using actual data from your data tables when you are explaining this. So you kind of did this already in the trend section, but you want to use actual data. So if I go back and look at my data table, when the concentration was 1.0 molar, the reaction rate was 0.02. When the concentration was 3, when the concentration increased, the reaction rate was 0.1. So did it increase or did it decrease the reaction rate when I increase the concentration? I'll do the same thing here with temperature. So again, I'm going to cite when my temperature was 10 degrees Celsius, the reaction rate was 0.02. When the temperature was 75 degrees Celsius, the reaction rate was 0.1. So as I increase the temperature, what happened to the reaction rate? Okay, that's all I need here in the conclusion. All right, the final two sections are explanation and citations. So in the explanation section, we want to include at least 2 sources of experimental error. And here we don't want to say just human error. Depending on which class you were in, maybe you had different results happen depending on if you were using the starch that was made fresh early in the day or if it was made later in the day. So what happened when you were timing the reaction? Did you have any issues when you were timing it? Did anything unusual happen with the solutions, with the color changes? So just some things to think about. So you want to talk about those. You want to give at least 2 sources of experimental error, and then give suggestions on how someone could improve or fix the experiment if they repeated it. Okay. So the color change is a result of the starch solution. And I know that when we were doing the lab, this was mentioned. So just keep that in mind when you're writing out your sources of error. All right, the final section is your citations. So you should be able to just copy and paste the citations from your pre-lab here, and you're done. That's it.